Okay, so in lesson 3, we're going to look at the area of triangles other than right triangles using the height and the base. So the first part here wants us to draw and label the height of the two triangles and classify both triangles. That just means to give it a name. So with the first triangle, in order to draw the height of it, we would have to draw outside of the figure. So now remember, your height has to come out of your base and go to the opposite vertex at a right angle. So no matter how I do that, here I'm not getting to a vertex, here I'm not getting to a vertex, and here, yeah, it's not going to work. So what I have to do here is draw, just like we did before, I'm going to draw an invisible extension to make that right angle to the opposite vertex. Okay, so here would be my height, this would be my base. Now, when I say my base, I'm just talking about the point, the line segment within the actual triangle, not this extension that I've drawn here. That is not the base. Now, this type of triangle is called an obtuse triangle. We didn't talk about this the first lesson. It's an obtuse triangle because one of the angles in that triangle is greater than 90. Okay, so that is what it means. You have one obtuse angle. Okay, so now if we look at the next one, we can draw our base and our height either within or without the figure. I can get from this side of the triangle to its opposite vertex at a right angle. So this could be considered my height. I can also extend from here to make the height this way. These two would be the same. Okay, and this is my right angle. So it's all about how you look at it. There's a whole bunch of different ways you can draw the height. Like I could have drawn the height over here by extending this to this. Well, a little high, but this should be the same length if they were drawn correctly. I can also do it this way. It's just how you kind of look at it. But you do want that base, so that's why if I just want the height, that's fine. Okay, so this one is an acute triangle. And it's an acute triangle because all three angles are acute or less than 90 degrees. Okay, so it's asking them to do a couple of different things here. So we're given a triangle. It wants us to find the area of the two right triangles formed inside of it based on the height. So we're going to separate it into two separate triangles here and find the area of both and add them together. And then see if our formula, either this one or this one, would work regardless. So if I wanted to look at two right triangles, I'm going to use the base times height divided by 2. So we've learned that a right triangle is the base times height divided by 2 because it's a square split in half, a rectangle split in half. So for this one, we have a right triangle here, and we have a right triangle here. Okay, so these are both right triangles. So in one of our triangles, we have a base of 34 and a height of 32. And in the other right triangle, we have a base of 12 and a height of 32. Okay, so we're going to find the area of both of these triangles, this one, and then add them together to get the total triangle. So if I do 34 times 32, I end up with 1,088, which I'll then divide by 2. Don't forget the dividing by 2. That's the one thing that a lot of 6th graders do. We get 544, and it would be square meters. Then if I do 12 times 32, I wind up with 384, which I'll divide by 2, and that would give me 192. And again, it's square meters. So if I want the entire triangle, I would add the two right triangles together, and I would get 736 square meters. So now what we can do is we can see if our formula for a right triangle would actually work for triangles that are not right triangles. So if I wanted to look for the entire triangle, my base is going to be these two lengths that they've given us put together. So that means I would add 34 plus 12 and get 46. My height would still remain the same. It's still coming out of that base at that right angle. So I'm going to try the same formula and see if I get the same thing. So 46 times the 32 divided by 2. When I do 46 times 32, I get 1,472, and then I would have to divide it by 2, which would give me 736 square meters. So what this shows is the area formula for a right triangle also works for an acute triangle, because this is an acute triangle here. Okay, let's look at another example. The triangle below has an area of 4.76 square inches. If the base is 3.4 inches, let h be the height in inches. Write an equation that would help you solve for h using the area of a triangle formula, then solve it. Okay, so with this one, we can use either formula. Remember, yesterday I said that I prefer to use the 1/2 base times height. Now, what's interesting about this, too, is that because we're talking in terms of decimals, instead of using 1/2, I'm going to convert that into a decimal. And 1/2 as a decimal is 0.5. So I'm actually going to change the formula again, and this time write it this way. Okay, so now I have 4.76 as my area. I have 0.5 for the half, times my base of 3.4 times the height, which is the unknown. So I'm going to start by multiplying where I can. When I do 0.5 times 3.4, that gives me 1.7 times the height. Multiplication equation, I'll divide both sides by the number next to the variable. These cancel out, leaving me with the height. And if I do 4.76 divided by 1.7, I get 2.8, and it's in terms of inches. You can also, once again, do this with the other formula, area equals base times height divided by 2. I would have my 4.76. My base was 3.4 times the height divided by the 2. So I would do the division first and get 1.7h, and then it's the same process. So again, whichever one you're more comfortable with is acceptable. Okay, so now we're going to look at obtuse triangles and see if we can do the same thing. It's a little different with obtuse, though, because we can't create two right triangles with inside of it. So in this case, what we do is we actually use a rectangle. Now to do this, you'll notice they've drawn the height outside here, and what they would do is they would actually continue on with that and create a full rectangle around the outside of that obtuse triangle. So to find the area of the rectangle, we would use our A equals length times width formula. To find the area of this rectangle, we can clearly see one side of it is the 8, but the other side is this whole thing all together. So my part of my triangle plus my invisible line. They're telling me the part of my triangle is 24 and my invisible line is 6. So all together, this side would be 30. So what I would do here is I would do 30 times 8, which is 240, and it's square inches. Now this still does not tell me what the So this does not tell me what the area of the triangle is still. it's telling me this part, the whole thing out here. So all of this space. So what I would have to do here is then use two other triangles that are formed from this and subtract them out. So basically what it's saying is I'm given the area of this entire part, the rectangle around it. I'm trying to find the area of this triangle. So in order to do that, what I can do is subtract out the area of this triangle and this triangle to get the inside triangle. It's a lot of steps, but it's just to prove, you won't be doing this for everything, but it is just to prove that it would in fact be the same thing. So now, one thing to notice is that we have this triangle with some numbers here. So this I'm going to refer to as triangle 1, and this is triangle 2. So triangle 1, I would do base times height divided by 2, which would be 6 times 8 divided by 2, 6 and 8 at the right angle, which is 48 divided by 2, or 24. The second triangle, so triangle 2, I'll use the same formula. And in this case, I have a base and a height over here. So I could use 24 times, I'm sorry, not 24. It would be the 24 plus the 6, so it would be 30 times the 8, which is the same as this side because rectangle, and then divide that by 2. So that gives me 240 divided by 2, which is 120. So now what it's saying is take the 240 you got for the full rectangle and subtract out each of these other triangles. So minus 120 would give me 120, and then minus 24 would give me 96 square inches. A lot of work for one problem. So now what we're going to do is we're actually going to see if it would work just with the formula for the triangle. So base times height divided by 2. So now what's important here is our base is only what's part of the triangle. So just the 24. Our height is what we're getting from that imaginary line drawn outside. So this is my height and this is my base. When I multiply 24 times 8, I get 192. And then when I do 192 divided by 2, I do in fact get 96 square inches. So they are in fact the same. So we're not going to be using this very often. We may need to use this when we get onto the coordinate plane later. But it's just to prove that it does in fact work for the entire triangle. So drawing that outside will give me the same result.